Okay, so we're restarting. We're back. This is part two, and we're taking a look at an example here. The manufacturer with a video display wants a certain tension in millivolts in a screen with a standard deviation of 36.21. We want to construct a 90% confidence interval. And all right, so we want to state, plan, do, conclude. Right, so state, we want to estimate the true mean tension of all the displays produced at 90% confidence interval. We're given, this is from the book, we're given this dot plot of screen tension. And so we're going to say it's relatively normal. And then we're going to say, yes, it's independent. The 20 readings were out of 1,000 readings for the day that was described previously. So it's less than 1/10. So we met the conditions to do the evaluation. So now we're going to set up the values. I have U is equal to X bar plus T times the sample standard deviation divided by the square root of the sample size. Now I'm going to go to my table to get my T statistic. So a 90% confidence interval gives me an upper tail probability of 0.05, where I can use the calculator in order to find this using that inverse T function that we had previously gone through, and I end up with a value of 1.729. 36.21 is given, 20 is given for the readings, and I end up with an interval of 292.32 to 320.32. All right, so now we can also use a calculator to find this interval without having to go through these calculations, but you should know basically how they're comprised. All right, so we need the sample mean, we need the sample standard deviation, we need the count and the confidence level. And so we're going to populate that using this information here. So I'm going to populate that 306.32, standard deviation from the sample 36.21. Sample size is 20, and the confidence level is 0.90. So I'm going to go to my stat function. I'm going to be brought to this feature. I'm going to scroll over to tests. Then I'm going to scroll down to T interval. I'm going to click on T interval. And then I'm going to go to not data, but I'm going to go to the stats tab. And in the stats tab, I'm going to enter in the information here. 306.32, 36.21, sample size of 20, confidence interval of 0.90. I'm going to press enter, and I'm given 292.32 to 320.32 here, which corresponds to the value that we were able to derive by hand. 292.32, 320.32. So this is our interval. So we can get this interval through the calculator if we want to go through this process or if we want to do it by hand. All right, so that should bring us to, let me leave this up here for another moment. That should bring us to our homework problem. So I believe there's a third homework problem. Biologists are studying the healing of skin wounds measured. Biologists who are studying the healing of skin wounds measure the rate at which new cells close a cut made in the skin of an anesthetized salamander. Here is the data from a random sample of 18 salamanders. This is the measure in micrometers per hour that the cut healed. So we're going to define the parameter of interest. What inference method should you use? Are the conditions met? I'm going to construct a 95% confidence interval for the population mean and interpret the interval in context. All right. So this is your homework. Just showed you the answer. So I'm going to leave this up here for a minute. And then I'm going to move on. All right, moving on. All right, last thing we want to talk about, using T procedures wisely. All right, so stated confidence intervals are exactly correct when the population distribution is exactly normal. However, When it's not normal, then there are some considerations. So the usefulness of t-procedures apply more to normal distributions, and they're less useful when the distribution is less normal. So that means that we need to have robust procedures around distributions that are less normal or when it's not known. So an inference procedure is robust if the probability calculations involved remain accurate even when the condition is violated. So when the condition is violated for normality or when it's not known, again, we need to make sure that we follow certain procedures. So the first is when the sample size is less than 15. We're going to use t-procedures when the data appears normal, so single peak, symmetric, no outliers. If the data is clearly skewed, we're not going to use the t-procedures. If the sample size is between 15 and 30, we can use the t-procedures except in the presence of outliers or strong skewness. All right, and then when the sample size is greater than 30, we can use the t-procedures even for clearly skewed distribution. All right, so what we run into is when the sample size is smaller, then we have to follow some restrictions in using t-procedures. If it's less than 15, the data has to appear symmetric. If it's between 50 and 30, then if it's symmetric, but if there are several outliers and it's strongly skewed, then, or if it's less symmetric and there are outliers and it's strongly skewed, then we need to be careful about using t-procedures. And then finally, when it's greater than 30, we can use t-procedures even if the distribution is skewed. All right, so I'm going to go through some examples. We want to figure out whether or not we can use t, in this case, t-procedures. So let's determine whether we can safely use a one sample t interval to estimate the population mean in each of the samples. So I'm going to let you pause here and see if you can figure out whether or not we should or should not use a t procedure. And the histogram shows all 50 states and the percent of residents over 65 years. The answer to this is the t procedure is not required because we already know the population mean, and we can derive that from the data or the graph. It's kind of a trick question. All right, second one, can we determine whether we can safely use a one sample t interval to estimate the population mean in each of these examples? The stem plot shows the amount of force to pull apart a bag of M&Ms. And you can pause here to figure this out. In this case, we have a sample size that's 20 and the data is skewed left. So we're going to be cautious or we're not going to use it. And the third, determine whether we can safely use a one sample t interval to estimate a population mean. In this example, stem plot shows the stem length of certain varietal of flower. And the answer is yes, the data is only mildly skewed right. And the size is greater than 15. Right, so this brings us to homework. So there are two parts. The first part is going to be your homework, and the second part is going to be classwork, which we'll do in class. So a bank manager wants to know if agents are answering calls within 30 seconds. He wants to measure it in two ways, estimating the proportion of calls answered within 30 seconds to a 95% confidence interval using the data below. So you're going to state, plan, do, conclude. And then number two, we're going to take care of in class. So don't worry about number two for now. We'll do that in class. So I'll just cross this off. This is your homework. So please write this down. And that will be it for today. I'm going to give you a couple more seconds and then I'm going to stop the video. Thanks for joining. This will be the last section and discussion about confidence and confidence intervals, although we will continue to use them moving forward throughout what we will learn in ensuing chapters.